All right, guys, here we go. At this point, I've shown you how to work with quadratic equations and quadratic inequalities. Now we're going to see how we can use those quadratics to apply them in real-world situations. That's what we're going to be looking at today. And there's a couple of different methods that we can use. I'm going to show you two of them. All right, so on here we got applying quadratics. It says that producers for a Broadway musical notice that increasing the ticket price can generate more revenue. It makes more sense. You charge more for the tickets, you're going to make more money. But only to a certain point. At $50 per ticket, they expect revenues to be about $38,250. That's if they charge $50 per ticket. At $100 per ticket, the expected revenue is $49,500. So if they charge $100 for the tickets, they plan on making $49,500. If they charge $135 per ticket, they expect the revenue to be around $39,150. All right, so what we're going to use is, or we're going to do is take this data and use it to come up with a quadratic. Now notice it says there what quadratic function can be used to relate the ticket prices, which is going to be our x, and the expected revenue, which is going to be our y value or our r of x. Okay, so we are dealing with a function here. Now they kind of got us started on the table over there. Remember, our x values are going to be the ticket prices. Our y values are going to be the expected revenue. So, if we were to charge $50 per ticket, what were they expecting the revenue to be? What did it say in the paragraph? $38,250. So write that in. $38,250 is what they're expecting the revenue to be if they charge $50 for the tickets. Now, if they charge $100 for the tickets, they're expecting that revenue to be even bigger. $49,500 is what they're expecting. There is another one, though. They said that if they charge $135 for the tickets, they're expecting the revenue to be $39,150. So notice there's a drop-off there. Why is that? That's right. If you start charging too much, then less people are going to buy those tickets. Okay, so you got to find that balance there. So here's what we're going to be doing today. It says there's several ways to come up with a quadratic in the form y equals ax squared plus bx plus c. We can do that using those 3 points or data that they've given us. Now, first thing you notice here, it says, however, you must have 3 data points. Why do you think this is? In other words, in order to come up with a quadratic, you got to have at least 3 points. Why won't it work with just 2 points? Why can't I just do it with 1 point? Why do I need 3 points? To be more, well, we are going to get more. Obviously, the more points we have, the more accurate we're going to be. But why do I need at least 3? Why can't I get a quadratic with just 2? Oh, you're right. We are going to make a u with 3. Let me go back over here, guys. This is what we're trying to come up with. We're trying to get an equation in that form right there. And I'm saying that we need 3 ordered pairs. But we're getting closer now. What do you notice in this equation? It has an A, a B, and a C, which is what we're going to be looking for. An A, a B, and a C. So why do we need 3 ordered pairs? So that we can find A, B, and C. So write that down for me right there. Why do we need those 3 points? So that we can find our 2 coefficients and our constant. That's the A, the B, and the C. If I don't have 3 points, it's not possible to find those A, B, and C. Got to have at least 3. We can do it with 4, we can do it with 5, we can do it with 6, but you got to have at least 3, not with 2. At least not with this first method that we're going to be looking at. All right, so here we go. This is one of the methods we can use to come up with that quadratic equation. It says here a matrix can be used to solve a blank for A, B, and C. We talked about this the second 6 weeks. We can use a matrix to solve a system of equations. We use matrix to solve a system of equations. We did this, like I said, the second 6 weeks of school. So here's what we're going to do. We're going to take that data that they were giving us. They gave us 3 points, 3 ordered pairs, and they're right here. These are the 3 points. Now that first point, 50 and 38,250, the X or the 50 represented what? The price of the ticket. What did that 38,250 represent? The revenue. So all we're going to do is replace all the X's in our quadratic, this X and this X right here. We're going to replace both of those X's with our 50. The Y value, we're going to replace that with our revenue, which is 38,250. Once we got those plugged in, then it's a matter of simplifying. And that's right over here. That's the simplifying part. So notice what they did here was they squared the 50. 50 squared is a 2,500. What do you get when you multiply B times 50? B times 50 is 50B. Of course, C remains the same. And we still got that same revenue of 38,250. Take a look at the next point that they gave us. This one right here. This point was 100, 49,500. 100 was what they're charging for the ticket. 49,500 is what the revenue is expected. So again, if we plug in 100 for X, 100 for this X, and 49,500 for the Y value, this is what it looks like. Of course, we need to simplify that. So that's what we're going to do right over here. We're going to simplify. So I need you to get your calculators out, and we need to square 100. What do you get when you square 100? 10,000. So now this becomes 10,000 A. When you multiply B times 100, you're going to get a 100 B. And you're still going to have your plus C, and it's still going to equal to that 49,500. That's going to stay the same. Let's do the next one. 135, again, that's what they're charging for the tickets. 39,150 is the expected revenue. So let's plug in those numbers like we did the others. So we're going to do A times 135 squared plus B times 135 plus C equals, now the revenue they're expecting is 39,150. That's what they're expecting the revenue. So if I simplify that, I need your help here. I need to square 135. What do you get when you square 135? 18,000 what? 225? Y'all double check that and make sure that is correct. I need to multiply 135 times B, which is 135B. Still adding the C, and the total revenue we're expecting is still 39,150. All right, so what I've done is I've taken the 3 points and I've created 3 equations from those 3 points. And those 3 equations are right here. Those are the 3 equations. Now we have 3 equations with 3 variables. Now we're ready to use our matrix button on our calculator, right? Because that's what we're using to solve this and to come up with the quadratic. So now we're going to go to our calculators. All right, so let me pull up my calculator. You do the same. So here's our calculator, and we need to enter this data into that calculator. First thing we need to do is go to matrix. All right, so we're going to go to second, and then that x to the -1. That's where you're going to find matrix. The first thing we need to do is enter the data. So we're going to need to edit our matrix. So move over to the right to where it says edit, enter. What we're going to do is we're going to edit in matrix A. The first thing we need to do is tell it what size of a matrix we need. Anybody know what size we need? 2 by 3. We're going to need 2 rows and 3 columns. So up at the top, if it doesn't say so already, make sure you have a 2 by 3. Are you sure about that? Remember, if you look at the equations, we have 3 equations, so we're definitely going to need 3 rows. So we're going to need a column for A, we're going to need a column for B, a column for C, and we're also going to need a column for that total revenue. So we're actually going to need how many? 4 columns. So let's go back up to the top. And let's make sure we have a, not 2, but a 3 by 4. There we go. So make sure you have a 3 by 4, because we need a place to put all of this down. So to get the first row, we're going to look at the first equation. In front of the A, we have 2,500. So that's the first number we're typing in there. Make sure you hit enter. The second number we're typing in is 50. That's the number in front of the B. The next number I need is the number in front of C. What number do you have in front of C? 1. You need the 1. The last number represents our total revenue. In this case, it's going to be 38,250. There's our first row. Notice it takes you down to the second row automatically. The second row of numbers is going to be 10,000, 100, 1, and 49,500. That is our second row. And this came off of our second equation. Uh-oh, did I miss something? That should be 10,000. There we go. That one should have been 100. This one is 1, 49,500. And the last row we had, what was that, 18,225, 135, 1, and 39,150. All right, now that we have all the numbers in, let's clear this out. Second mode. Quick, get yourself a nice clean screen. Once you get a clean screen, we're going to go back to Matrix again, where we were at earlier. But we're not going to edit this time. What we're going to do is we're going to move over to the map. And the one we've been using is that RREF. That's that reduced row echelon. That's the one we're going to be using. So it's down towards the bottom. Here it is. Make sure it has 2 R's. RREF. Hit enter. Now it's not going to give you anything yet because it wants to know where are your numbers. So let's go back to Matrix one last time here. We put all of the numbers in Matrix A, so let's select that. Close up your parentheses. And now let's hit enter. And now you're going to get this funny looking thing here. Remember, this first value they give us up here, that negative 6.12605, that is going to represent our A. The 1,143.907 is going to represent our B. And that negative 3,630.252 is going to represent our C. So we're going to write those numbers down way over here. So right here, we got 1,143.908. That's our B. Our C was 3,630.252. So those 3 numbers that we just found represent our A, our B, and our C in that quadratic equation. So down at the very bottom here, now we can write the quadratic. Notice they've already got it started here. They already plugged in the first number, A. B is going to be that 1,143.908. And our C, our constant, is going to be the negative 3,630.252. And that is a negative. All right, so this is our quadratic equation. When you come up with that quadratic equation, we had to use this reduced row echelon. That's the method. Now, there is another method to come up with the same exact equation, and that's what we're going to look at next. So let's take a look at this one here. There's an alternative, and the alternative is to use your stat button. Everybody go to stat on your calculator here. Go to stat. And in stat, what we're going to do is we're going to edit. And what I need you guys to do is in L1, we're going to put our X values. And that was the 50, the 100, and the 135. Remember, these were the ticket prices. This is what they're selling the tickets for. Right next to that, the Y values represent the total revenue. So we have 38,250. We had 49,000, what is it, 500? And the last one we had was 39,150. All right, now that we have the values in our stat, now what we're going to do is go back to stat. We're going to calculate. Now usually what we've done is we've done a linear regression. This is no longer a linear function. We've got a quadratic function. So what we're going to do instead is we're going to calculate a quadratic regression. So go down to number 5. That's the quadratic regression. And you're going to have to enter a couple of times here. And this is what you get. That's something you guys got? Now notice they give us 3 numbers, an A, a B, and a C. What do you notice about these 3 numbers that they just gave us? They're the same numbers that we got earlier. So, on a test, if I told you you can use any of these 2 methods to come up with a quadratic, which one do you think would be easier? The stat. Right? Now matrix, of course, you're going to have to do a little work to get it into your matrix, but I think probably the quadratic regression is going to be a little faster and a little bit easier. However, you do have those 2 options. Right? You have 2 options. All right, so what I need you guys to do now is get out that other paper. The other paper, the applications, that's the one we're looking at.